If we look at that equilibrium constant in a little more detail, we can see some mathematical relationships. Since all reactions can be thought of as forward or reverse, if I write this reaction in the reverse direction, and I'm going to get lazy and not put my states because we know what they are, then my new equilibrium constant, which is not the same as my previous one, so let me make it put a prime on it. My new equilibrium constant is going to equal H2 concentration times I2 divided by HI squared. You will notice the mathematical relationship between these two reactions. If I reverse a reaction, I take 1 over, I flip, if you will, the equilibrium constant. So my new reaction, once it's reversed, has an equilibrium constant that's equal to 1 divided by the old equilibrium constant. Reversing a reaction flips the equilibrium constant. If, for whatever reason, I needed to write the reaction, let's start with this blue one. Let's say I needed to write the reaction as 4HI is in equilibrium with 2H2 plus 2I2. Then look at what happens to the equilibrium constant. And again, it's not this one, that one, it's a new one. Let me call it a double prime. If I write this new equilibrium constant expression, I end up with H2 squared times I2 squared, all divided by HI to the fourth. Mathematically, these two equilibrium constants are related in that my new equilibrium constant is my old one squared. In other words, everybody is simply squared from this expression to give me my new equilibrium constant. I multiplied the reaction by 2, and this raised each of my concentrations to the second power. So when you multiply a reaction by a factor, you will raise the equilibrium constant by that factor. If I have to multiply an equilibrium reaction by 3 for whatever reason, then the new equilibrium constant is the old one cubed. If I have to take all of my coefficients in half, then my new equilibrium constant is the old equilibrium constant raised to the 1/2 power, which is the square root. So we can manipulate equilibrium constants mathematically if we have to manipulate the reactions. And there will be times that we do have to manipulate the reactions.